So hello everyone. So in this video, I'll explain my work for the project IR. So for the question 1, it asks to write a program that will read a file, whether it is TXT format or PDF format, stored in my storage. So when we run this code, we can see that it runs the code and show the file list and its content, and the read all PDFs in folder function checks if the folder exists and then sort them, reads them one by one, and prints the content. For example, when we run the script, it reads multiple PDFs in order. For example, like the p1.pdf, this right here, talks about generative AI, and we can see also here is the p2.pdf file, which talks about quantum AI, and so is the rest, the p3.pdf, and then p4, and then following until the p10, which is the last file that stored in my storage. Alright, so for the question 2, it has to read all the text files and construct the TF-IDF for the sample collection after removing all the stop words and performing the stemming process. So as we can see here, we pre-process the text, the text processes text, and then this function actually converts the text to lowercase and tokenizes the text, splitting into words, and removes stop words, common words like the, is, and so on. And it also removes the punctuation and applies stemming, reducing words to their base. For example, running to run. And then after that, we compute the TF-IDF. It helps to determine the importance of words in a document. The script creates a TF-IDF vectorizer and computes the TF-IDF values for all the processes document, and then it prints the top 10 most important words in each file along with the IDF scores. So if we run it here, we can see that, now we can see that the number of files that being processed is 10. So it reads the p1.pdf first, the file first, and then it shows the TF-IDF score. For example, this one, generative, it has 0.4700, and then for this file, p1.pdf, the script extracts a discussion on the generative AI and identifies gener AI and content, like we can see here, as the most relevant words based on the TF-IDF scores. Similarly to P10 here, the P10 file focuses on AIoT, with AIoT smart, and device being the key terms here. As you can see, AIoT has 0.4377 scores, and then smart 0.3189, and device 0.2067. And following the rest until the last of the file, which is the P9. So for the question 3, the question is, the given a query queue, rank the text files based on the given queue. So as for the code, we can see that there are many functions. For example, we see here is the extract text from PDF files, and we can see the pre-process text, stop word removal, and also stemming here. This one, yes, this one. It converts the text to lowercase and tokenizes text into words, removes stop words and punctuation, and applies stemming to reduce words to their root form. So we can see also here is the rank documents by query. It reads all the PDFs in the specific folder, and it extracts and processes their text, computes the TF-IDF matrix for all the documents, processes the user query and transform it into a TF-IDF vector, and computes the cosine similarity between the query and documents, and sort document based on similarity scores in descending order. And then when we run the code, we can see as to enter a query. So for example, we take this query right here. Digital twin is related to generative AI. So I click the enter, and then it shows us the rank based on the similarity score. which is the rank number 1. We can see here is the p8.pdf with 0.520310, which is the rank number 1, and then following by rank number 2, 3 until 10, based on the PDF file that being stored in my storage. And the similarity score is also, we can see here, is different for each file. So moving on to the question 4, given a query with at least 5 words and a threshold on the frequency of term sets set by the user itself, we can compute all the frequent term sets for the given queue. So how we can analyze and rank documents based on frequent term sets using Python. Imagine we have a collection of PDFs related to generative AI. We want to analyze them by identifying the most frequent word combination based on user queries. So for the first step is we extract text from PDF and then pre-process the text and generate the term sets. For example, when we run this code, it will ask the query, and we can set here digital twin AI. We can set here, digital twin is related to generative AI. So we enter the frequency threshold, which is 1. We can take here as 1. It will show us the frequent term sets in the query. So the term AI appears in P1.pdf, P2.pdf, P8, and P10. Digital also found in P4, P5, P7, and P8 file, and generative P1, twin P8, what else? The related P9, and this helps users quickly find relevant documents based on the term frequency. This script is useful for information retrieval, helping researchers, students, and professionals efficiently locate relevant documents, and we can improve it by adding the TF-IDF weighting and fresh best matching for better accuracy. Alright, so the last question would be the question number 5, which is the given a query queue ranking of document produced in question 3, and the markers of all relevant documents as long as the document consists of one terms in queue. Compute the position of the retrieval system at any position given by the user. For example, 3, position at position 3 of the ranking. So we can see here in this project we have a collective of PDF documents related to generative AI. Our goal is to rank this document based on a user's query and measure retrieval effectiveness. So how it works is we extract the pre-processed text and then compute the TF-IDF rank documents. And if we run this code, suppose we enter the query, which is so suppose we enter this query right here. Digital twin is related to generative AI. It will show us the document ranking. For ranking number 1, file which is the P8, with 0.520310 severity score, and it is relevant. And then we enter here is 5 at rank 5. It shows that this means that 4 out of the top 5 documents were relevant. So we can see here it is 1.0000.